The electric power section, and this is the first question. They've started many electric power questions with a question similar. You've been asked to draw the magnetic fields around something, bar magnets, solenoids or wires. So we've got the two solenoids here, currents flowing through their coils, both of them generate magnetic fields. Their combined field is much greater than the Earth's field. That means forget about the Earth's field, just forget about it. Sketch at least 4 lines in this space here. Mark the direction of each field line that you draw. Alright, I'm going to do some working down here. So the first one looks like this. We've got positive, we've got negative, we've got the current going around this way, and this is, I'm going to use my right hand solenoid rule. Solenoid enoid rule, where I take my right hand how many fingers have I got? 1, 2, 3, 4, yeah, that seems about right. And my fingers are going in the direction of the current. So they're curling over with the current, with the coils, just like that. So you can see how I've grabbed that there. The coils are going over, or the current's going over the top, and so are my fingers. And then my thumb points to the North Pole. So this is the North Pole here. Now a solenoid has the field of a bar magnet. So north, south, comes out of the north into the south. But there's another one as well, and this one's around the other way. Look at the batteries there. It's the same shaped solenoid, but it's around the other way. So that means, I mean, I could get my hand out and do it, but I know if it's around the other way, it must be, I must have the North Pole at this end of this one. Alright, so if you have 2 bar magnets, this is something we've practiced before, we've seen the field lines around it, and they are facing each other, north to north or south to south. They try and repel, and you get a field lines that sort of repel each other. They don't touch, but they repel each other like this. If you had a north-south and south-north, so opposites, you've got that they actually go into each other like this. That isn't what we've got. We've got north to north because we've got the north end of this. We've got the current going around and going over the top backwards like that. If you tried to do your right hand like that, you'd have your fingers going around this way, and the rest of your hand is kind of, your thumb comes out here this way. It's an awful hand, but your thumb's out that way pointing to the north, which is here. So we've got a north at this end, a north at this end, and because of that we've got these as though we've got 2 bar magnets, north and north, so we can draw our field lines like this.